Hi guys, the afternoon. Today we are going to discuss about the concept of 3D printing technology. Myself, Dr.K. Arun Prasath. I am working as an assistant professor in the Department of Mechanical Engineering, PSN College of Engineering Technology, Technology. Okay, guys, please listen. Now we are entering into the concept of 3D printing technology. I hope my screen is visible to you. So please listen. Yeah, I hope you it's visible. Okay. So the 3D printing technology. Before we are enter into the concept of 3D printing, guys, please listen. Before we are enter into the concept of 3D printing, okay, we need to know about some basics of it. You people may aware of so many concepts which related to 3D printing nowadays. Something else you can see anywhere else, or any of the application areas you can hear people they are speak about 3D printing, 3D printing, 3D. So guys, where initially we are start with the concept of 3D printing technology, before we must understood what is 3D printing. Okay, guys, in earlier days where people they are had drawing the components by means of using scales and pencils. Okay, there are specialized persons that they are who is called as mechanist. That mechanist draw the component of all the elements what we are using nowadays. For example, connecting rod or piston, whatever may be. These connecting components are drawn by using scales and pencils. But then later, people they are discovering so many of softwares, design softwares like AutoCAD, SolidWorks. Okay, then nowadays we are using Creo elements. Okay, then Autodesk Fusion 360. So all these softwares are developed later. The initial stage of this area of design, people they are having only two dimension. That two dimension is X and Y. Okay, we can draw whatever an image or whatever a component. Okay, these component have only two dimensions, but laterally people they are developing their stages by means of technological development. They need some new concept to introduce in the world by seeing that image or seeing that component visually how it should be there in the printed part in the sense after the completion of the drawing, how the part is lively available. So only the researchers discovered a new concept to develop for an prototype making initially, that is called as 3DP technology. 3DP technology is nothing but where we are seeing that component in three direction. Okay, we can seeing that component in three direction X, Y, and Z. In this three direction, we can see the component in how it really available or how it really there after the design stage is completed, because we just simply design in the design stage we will giving all the dimensional details for the drawing. After the dimensional details is given for the drawing, through this 3D printing technology we have that model in our hands. Okay, so once we are seeing the live model, where we have that idea whether we going to improve any design changes or what else maybe we can see the component lively, then only we have that idea. So for that purpose only initially people they are developing the concept 3D printing. So 3D printing where is also called as rapid prototyping, where this 3D printing and rapid prototyping both are having same meaning, but these two are come under the concept of additive manufacturing. Additive manufacturing is the principle. The 3D printing is the application of that additive manufacturing. Okay, so now the trend is 4D printing. Okay, 4D printing is nothing but where we just printed our same story or same process what we followed till the design state. But after the printing is completed, guys, please listen. After the printing is completed, what happens means the material get deformed. You people are heard about shape memory alloys. Okay, shape memory alloys is nothing but where we can apply any disturbance by means of heat or by means of any cold environment. What happens means it turns to deformation. Okay, whether I am applying heat, it will deform. Then again I am applying any reduced temperature or cold environment, it get transformed into newer position or it come back to its original position. So all materials not at all supporting for this 3D 4D printing technology, but the safe memory alloys, especially they are supported for this kind of application. This 4D technology is now is there in the developing stages, but people they are using all the types of materials, especially polymers. Okay, then if you want to using metals, also we can print out with our 3D printing technology. So many technology is available in the 3D printing technology where with the application of our additive manufacturing. This is the basic introduction, guys, about our 3D printing technology. Now, in this first video, we are going to see about the basics of our 3D printing. Basics of the 3D printing from the principal stage to the designing stage. Okay, in later videos, we are going to discuss about the next chapters by means of some applications and individual process principles and methodologies and everything. Okay, now listen. So, introduction to 3D printing technology, where I give you the basic introduction. So, 3D printing technology, the reason why people they are preferred this 3D printing technology is to visualize the component of the design. So, once we are having a component in our hand, we have some idea. Then another important thing is the 3D printing technology, where it doesn't require a big structure and at all. While we are seeing our 3D printers, it looks like a common printer what we use in our office. Okay, but the process is completely changed. But it just looks like a small printer. We can print the component instantly. Okay, then this technology is very newer technology, and we have the outlook as it is possible the component what is there exactly. That is the main advantage of this 3D printing. Then we can reduce the material wastage. Once we are moving with our normal machining process, because you people are from mechanical engineering background, you may know about that the basic concept of our machining. The basic concept of our machining, whenever we are going to create any of the component. For example, we can take lathe. Okay, in that lathe, if you doing some shaping you can doing some plane turning operation or turning operation or facing operation, whatever may be, it happens only due to the material removal. Okay, I hope you people understood what I am saying. It only follow the material removal. If I want to put a hole in a drilling machine, there is a material removal is there, then the hole is to be happened in that piece material. But this 3D printing technology is not like that. This is called as additive manufacturing technology. Okay, so this additive manufacturing technology is the technique where it helps to reduce the material wastage. So that technology is called a subtractive technology. We discuss about this difference between additive manufacturing and subtractive manufacturing in the forthcoming slides. Now listen. So this is the history of our 3D printing. Same, the 3D printers was first introduced by Hiro Hodama. Okay, he's an researcher, scientist from Japan. Okay, where he just discovered this. First, he just coined this first name 3D printer in the year 1980s in a lab, okay, in Japanese lab, where they are the first 3D printer they are introduced is called as fusion deposition modeling (FDM) in the year 1980s. In later by 1984, okay, Chuckle, who worked in the 3D System Corporations from America, who he discovered a stereolithography machine in the year 1984. So this stereolithography machine where people they are using that photopolymers. Normally, photopolymers is nothing but the polymer which can easily cured with the help of the ultraviolet rays, because ultraviolet rays are lasers. Okay, we can easily cure this polymer in the time of the printing. Okay, this is some basic history of our 3D printers. Then later so many techniques are developed. Initially they start with fusion deposition modeling, then lithography they are introduced, then later by in that lithography they are introduced radio laser sintering, then laser stereolithography they are introduced, then inkjet printing technology they are introduced. Okay, there are so many printing technology they are introduced by using laser. They are having some printing technology. So many technologies are introduced in later. Okay, guys, this is the basics about 3D printers. Nowadays, the application of these 3D printers, even though they are using in the medical field also. Okay, for your information, where they are creating some artificial organs. Okay, like tissues. Okay, or bones. flushes, whatever may be, okay, nerves, even though they are creating, they are printed heart, okay, human heart functioning with the help of this 3D printing material. I will show that live example to you in the forthcoming videos, because we are in the starting stage, guys. First, we need to understand what is the 3D printing technology, how it works, okay. So, guys, don't hesitate to ask any doubt with me. If you have any doubt, please share your doubt with me in the chat box, okay. Otherwise, in the comment box. Fine. This is the roadmap where we are going to see something about 3D printing in this video. Okay, initially we are discussed about that history, then technology, then types, what are the materials, then applications, then it's simple. It moves with our some of the areas. Okay, so in later by 1980s to 90s, the 3D printing machine slowly entered into the real world of application. But people, they are taught initially, the only the mechanical people who are, especially people who are working in the automobile industries, they created this component for their study. But later by 1980s, then after that, nowadays up to 2000, 2010, okay, where we are having this 3D printing technology in all of the areas. It's not limited to till now. You can take any of the field. You can just simply enter into a aerospace industry or marine industry. Okay, some of the components are small gadgets. People, they are developing using this 3D printing technology. So these 3D printings have that ability to print metal also. That is called as laminated object modeling. Okay, in this LOM technique, we can print our simple metals also for our purposes. Okay, then now before we are going into the real concept, there are some basic procedure is there. Okay, the procedure in the sense how the 3D printing is developed. Okay, you people know by means of this video, we have the 3D printer with us. We have the printout, the component outside and everything. But the real concept is there are two processes involved here. Process number one is we just design our part. Okay, we for the design of our part, we can use SolidWorks. Okay, okay. Otherwise, we can use this. Wait, I will just enlarge it. Okay, we can use SolidWorks, or we can use CATIA, whatever maybe. Okay, CATIA, okay, SolidWorks, Rio Elements, Auto, sorry, Autodesk. So these are some softwares available for the design. Okay, while we are taking this design, guys, we need to separate the design into two categories, because the software may differ the application, because based on the application we are developing the softwares. Okay, we have this SolidWorks, Creo, Autodesk for then AutoCAD for the design. Okay, then after design is completed, we need to see the motion of the components where after the application. Okay, because before moving to the application, we need to analyze how much stress it can withstand, how much temperature it can withstand, or how much amount of load it can withstand. For that analyzing purpose, we have the analyzing software, example ANSYS, CATIA, even though. Then after this everything is completed, we need to see the output. Okay, by means of manufacturing. For that purpose, we are using CNC and 3D printers. So this is the hierarchy. Once we are follow this hierarchy, only total system going to be completed. Now listen to me. So first one is we need to draw our diagram with the help of these tools. Once the diagram is completed, the second step is I am just to import this diagram to that separate software people to access that printer. The software is used to access the printer. Here only the design is completed. Once this diagram is imported to the specialized software is called as Macus Cura. Okay, Macus Cura is one of the 3D printer software where we are extracting, and if you want to see some changes or how much amount of material is required, how much time is required, all the information like CNC machining. Once you upload a component in CNC machining, you can see all the things in the display. Now, similarly, once we imported your image through Maker's Cura, you can see how the image is printed, how much material is required, everything, all the information we just we can get the information through this Maker's Cura software. Not only Maker's Cura, so many softwares is available. So Maker's Cura is one of the predominated software which is preferred by all of the industries who are using this 3D printing technology. Okay, once we are imported here, we can have all the information. Then finally we can get our printed component. That the only drawback of this 3D printing is time. Okay, it took more time. Okay, it took more time. The reason for this, guy, there is a concept is called as meshing. Okay, meshing is the concept where it can created some internal structures like this. Okay, you can see that board, you can easily the structure like this, where this structure is very fine. We will get the very good compactness in the product. Okay, if the structure is very fine, we are having very fine structure, the material strength is very good. If the meshing is not correctly, obviously we are failed in the technology, and the material doesn't withstand some amount of load what we required or we need. Okay, so because for creating this type of meshing in the component, it took some time, because this creating a square like shaped or some types of honeycomb structure. So it took some time to create that structure. Then only the build quality of the material is very good. That is the only drawback of our 3D printing. But if you want yeah, mass production is also possible. You can run with multiple machines. That is the only solutions so far is available. So the first step is we just draw the image with the help of some of the design software. Then we can import that image through any of that our 3D printer softwares to see the other informations like how much time required for printing, how much material is required, what is the possible direction of printing, and everything we can clearly seen through the Maker's Cura software or some other software which can access our 3D printing. That is the image they will give. First virtual model, then the CAD model is imported to the some of that component what we used here. Then it printed the object. So the file preparation, in the sense, each and every printer it has its own file preparation. Normally the default file conversion is .stl. The default conversion is .stl. Okay, .stl format is the format where we are saving our CAD files. Okay, CAD files you can stored in the form of .cadd or some other extension where this file is converted to .stl. Then only it will imported into the Cura software or whatever softwares we are using. Okay. So that is the concept where they are creating. So don't get confused, guys. But nowadays the technology is developed where CATIA that interlinked. Okay, the CATIA the interlinked the technology with printers where we can drawing, and directly we can connect the printer to our CATIA software and we can print it. It possible, but only CATIA have the accurate license. Okay, with 3D printers developers where that Cura 3D printing technologies, where Cura can give that access to CATIA till now. But forthcoming days where all the things are very easy for us, where we can expect this technology, where this connection with all of our design softwares, where there is no separate softwares to split this in like two stages. Okay, we can draw, we can print through our printers. Okay. So guys, this is this additive. In the earlier of our video, we just discussed about the concept called subtractive manufacturing and additive manufacturing. Yeah, I will give you a very good example to you guys where that additive manufacturing is the technology where it creates the objects layer by layer like this. Inside that, I am speak about that meshing and everything. Okay, this is called as additive manufacturing, where the component they can create like this. But subtractive manufacturing is like this. Okay, where the material is removal is happens. After the material removal, we will get the extra part. But here there is no material removal is there, and there is no excess material is not required for this case for the building. But in this case, we are having that material removal in the form of waste. But here in the substitutive manufacturing, or in the additive manufacturing, there is no requirement of excess material. Only the material what is needed to build that component, it can be produced. Okay, this is the difference between the additive manufacturing and subtractive manufacturing. Okay, guys, that's the diagram where they are showing. See, this is the complete model where this is the layer formation of the model. Then another technology, without doing that drawing and everything, that the scanning technology. Simply the scanners are available. We can scan. This technology, people they are implemented in the making prototype model as it is. Okay, if I want to draw a statue, or if I want to print a statue of one of our leaders, we can use this scanning technology simply without drawing. It can simply give that all the images, and these images will be loaded there in the screen, and we can easily print it through our printers. Okay, this is one of the technology. Then same thing. Then material what we are using mostly, guys. These 3D printing materials are preferred towards our plastics. Okay, plastics in the sense the plastics are classified into two categories. One is thermoplastic plastics, another one is thermoset plastic. Thermoplastics in the sense where it can change its phase when I am applying heat. Okay, I am applying some heat, it converted into powder. Again, I am applying the heat, it will come back to the liquid portion. Okay, thermoset in the sense the best example for thermoset is our PVC pipes. Okay, only heat it will convert it into solid. Again, I am applying heat, it won't revert back to its original liquid portion. So most of that our 3D printing materials, plastics may hold on. In that plastics, some of the biodegradable plastics are available like PLA. Okay, then ABS, these are some of the biodegradable plastics where people they are mostly preferred these materials like PLA, ABS, nylon. But depend upon the application, guys. Please listen. Depend upon the application, these materials may change. Okay, I'm already giving the word to the introduction where we are using metals for printing also. Okay, this is some of the example for this one. Okay, yeah, this is the diagram which represents the additive manufacturing and subtractive manufacturing. This is the material where subtractive manufacturing where the material is removed. The required amount of material is only stay back. The remaining material is comes in the form of waste. Then again, this is the additive manufacturing. There is no material waste is there. Obviously, while comparing to our subtractive manufacturing, additive manufacturing have very less material waste. Okay, guys. Then the need for 3D printing technology, we are discussing so many things. Yeah, this is the prototype building. You can simply see this one. This is an fusion deposition modeling machine where they are. This is an MakerBot. Okay, this is one of the 3D printing company. MakerBot is one of the 3D printing company. Macascura is one of the 3D printing company. Where the MakerBot, where they are using Macascura. This is the software. Okay, likewise we are having so many. This is a 3D printing prototype. This is a 3D printing prototype of one a turbine. Okay, where we can using for the propellant of our rockets. Okay, so all the areas. Okay, they simply show the some of the applications of our 3D printing where we can having the artificial bones also. Okay, we can create artificial bones and everything. Okay, even though the technology is increased where we are having that functioning of heart in also. Okay, artificial functioning of heart. I will show that video in the later slides. Okay, guys, please listen. Where this is the 3D printing technology, common 3D printing technology, fusion deposition modeling, laser sintering, serial lithography, and quantum. So from these basics, there are so many components are there. So that's why we are seeing the basics. Okay, the technologies where we are seeing first fusion deposition modeling. Okay, where fusion deposition modeling where we are having two extruders in that. Okay, two extruders in that. In the two extruders, we are just simply having a materials where the extruders are simply absorb the materials and they print it like this. This is like this. Then selective laser sintering, where we are having a bath. In that bath, we are having that liquid polymers is there. Okay, we are simply absorb that image through a scanner or any of the design software. Then that image is imported and simply that scanner passes the image towards that liquid bath. Okay, once the laser is passed through, it is cured. Okay, then powder binding, the same technology. Instead of liquid we are using powders. For binding we are using lasers only. A stereolithography, where we are just simply dipped that material into a resin, okay, where in that resin we are dipped our component. The same here also, laser plays the main role. We just simply directed the laser into that liquid bath. That liquid bath printed the final component. Okay, the resin is nothing but, guys, this is also one of the polymeric material, where people they are using this material, these resins for binders in the polymer matrix composites. People they are using this resin as the binders. Binders is nothing but it's an agent which helps to combine to the light gum. Okay, don't get confused, like a gum. Then polyjet is nothing but same here, guys. That the difference is in that selective, please listen to the scheme, in the selective laser sintering, okay, where we are having the material melted in the bath, materials directly melted in the bath, same material in the form of powder in the powder binding, same material where we can dip it inside the resin bath, that is called as stereolithography. Okay, so I hope you people understood the difference. Then polyjet in the sense, same in the stereolithography, instead of laser we are using that UV ray to Q, that is called polyjet printing. The laminated object manufacturing, in this laminated object manufacturing, people they are using for metals. It is like a metal sheet, where the metal sheet, where through the help of the laser we can print our components. Okay, these are some basics technologies of our 3D printing. In later videos we are discussing in depth about what are all the 3D printing technology is available. Same concept. Okay, I am showing explaining that the image, same concept. The material normally people they are preferred polylactic acid. Okay, for a 3D printing, the most of the components through PLA and ABS. Okay, then some application. Yeah, earlier video I will set the same in the starting of the video earlierly. Okay, so the material may differ. There is no desired material for this process. Based on the application, we can change the materials. Okay, there is no constant concept is there for the systems. And applications, in the area of application, we are 3D printing. We are having in the area of our electronics. We can manufacture sensors, PCB board, and sensor mounting elements. Everything we can print it with the 3D printing models. In the area of medical, the aesthetics, okay, the prosthetic arms of our human body. Then we can print the small piece of bones and whatever may be in the form of replacement. Okay, these are some frontier development of our 3D printing technology, as well as in the area of SN technology, archaeological, automobile industry. Mainly the most more amount of percentage of utilization of this 3D printing technology is the automobile industry, then aerospace industry, then industrial designs, packaging industries. Okay, the biodegradable materials. Okay, this is one of the latest trend in nowadays. People they are looking for a biodegradable material replacement for plastics. So we can print some of the PLA component through this biodegradable concept, and we can give, obviously we can use this one in the instead of plastics. Okay, then computer gadgets. These are some basic applications of areas. So what are the component is there, guys? Already I said in the fusion deposition modeling, there's the extruder is there. Extruder is nothing but where it's a roller like structure. Okay, it's a roller like structure, where in this roller we just feed the that material like this. We can feed that material like this, and we can through a spinner, where this spinner can pass the material in the bath. Then we can applying a laser or whatever component, we can start our printing. Okay. This is the normal happens here. So a barrel screw, a feed pipe, okay, a screwdriver motor. These are normal things available there. Then some other parts, such as stepper motor and servo motor, is normally available. I hope you people know the difference between stepper motor and servo. Servo motor, we have that direction of rotation in only one direction. Either the clockwise, in anti-clockwise is normal motors what we seen in our fans or our real-time motors which can usually in the borewells. This is our servo motor. But the stepper motor, you have the same but it can pick by means of some piece of rotation. Okay, best example is escalators. In the escalator, people they are preferred this stepper motor because the rotation and the operation of this stepper motor is step by step between the intervals. First rotation 1 minute, second rotation 2 minutes. Likewise, between the intervals, this stepper motor rotates. Okay, so here we are using the stepper motors here, and the sensor, inductive sensor, the sensors may differ, guys. Okay, there is no constant sensors we won't design for an 3D printer. Okay, based on the purposes we are having so many sensors is there. Okay, if we want to locate the temperature, we are using temperature sensor of the bed. Okay, so actually, guys, in the 3D printer, yeah, we are seeing that 3D printing structure in a later video. Okay, so we need to analyze the temperature of the belt. Okay, then this synchronous belt where you have the connection between the movement, because we are looking for axis movement like this, like this, like this. So this belt acts as an direction control between this the microcontroller unit which controls the motors. Okay, purely it controls the motors. Then shaft, it can act as an mounting elements which controls the rotation of the motor. The temperature indicator sensors. Okay, some examples of 3D printing parts were in the textile area, the 3D printer bicycles, cars. Okay, then some of the component applications you may see here. There are a variety of applications is available here. Okay, the design model may have steps of calculations for design. Yeah, initially we are do the design like this. They are using a CAD software, AutoCAD here. They do the design software. The once the design software we need to save in the STL format, because already I am said the STL is a universal format where we are using for what else printed we are using. We have saved the 3D printed image in the STL format, then imported in the slicing software. Actually, the software name is called slicing software. What I am said, Makascura is one of the slicing software. In the slicing software, we just simply imported this image and we can see all the information. Time for printing, material required, way of printing it, and everything, how much amount of material is required. All the information we just simply see. This is simple the layer by layer formation. The information is available here, how much quantity. Okay, what is the bottom speed, filament diameter, dimension information. Okay, then everything is completed. Simply we can save in the G code. Same this G code we just using for geometry code for printing. Okay, after completion, in earlier days people they are having separate tool, but nowadays we can having the direct connection for the print. Okay, the printing is happens, we can easily we can have our components. Then vapor smoothing machine, this is one of the advanced technology where the ABS machine can printed through this one. So through this vapor smoothing technology we can get some very good output in the component after printing. But how this is an additive manufacturing technology. There is no extra material removal is required like normal machining operation. After machining operation is completed, to get the smoothness of the material we are preferred grinding, but here that's not required. So we have a very good output here. Okay, yeah, this is the structure I want to show you. Here you can have 10% meshing, 30, 50. So in this three variant, the 50% of meshing of the component have very good strength. So again, the application plays the key role. If we want a very high strength application of the material, we can prefer it very good mesh. That's the concept here. Okay. Then some analysis here. So maximum amount of users of this one, I am already said automotive industry they are using 25% of this 3D printing technology because they require lightweighted component for their application. So obviously metals are not suitable. So obviously we look for the replacement. That replacement is 3D printing components. Okay. Then most of the companies in all the areas they are using adopted this technology, and in forthcoming videos I also uh, show you some case studies where who are all using this 3D printing technology and what are all the outcome from that 3D printing components. Everything we are seeing in the forthcoming videos. Thank you guys. If you have any doubt, don't hesitate to ask me. Please, I will share my email ID here. Okay, you can contact me anytime. Thank you. Thank you for listening. I hope we will see in the uh, a new video in forthcoming days. Thank you guys. Thank you.